Greetings everyone, and welcome to section 5.4, which is also on the standard normal distribution. Only this time we're going to be finding values from probabilities. So in the last section we learned how to compute probabilities given x values, or z-scores. Z-score is equivalent to setting the mean to be 0 and the standard deviation to be 1. Remember that a z is a measure of how many standard deviations away from the mean that you are. Now, of course, in order to do this calculation, you're going to need, if you're going to calculate x, you need to know also the mean and standard deviation. If you're calculating the z-score, then you don't need anything else. Or if you have the z-score, you don't need anything else. In this section, we're going to compute backwards. We're going to start with a probability and end with x, or z. So if you take a look at the following diagram, you can see that I have a little shaded area, and the question we can ask now is if this shaded area is 0.15 or some other value, and then the question we're asking is, what is this value of x or z? And how do you do that? Well, like last time, we're going to be using the online calculator. The one that I recommend is from the Hyperstats Online Statistics textbook at davidmlane.com, and I'm going to put a link in the description. And let's take a look at a screenshot, and you can see that here is the screenshot of the online calculator. And the big change is if you take a look at this, the option right under the graph, we're choosing the second option here. So notice that we are now using the second option. And then you put in the area that you're interested in. So here's the area 0.15 that we said, and we're calculating essentially a z-score because we are saying our mean and standard deviation are 0 and 1 respectively. And then one of the boxes that you check in the results area is our answer. So this is our answer. We're calculated as z is equal to 1.036. Now notice that you could tick different boxes. Below will give you the area below that. It will shade in the area to the left of your x or z rather than the right. And you can also do between and outside for symmetrical intervals, and we'll be using those later when we get to confidence intervals. So let's do another example. I'm just going to write example here. What value of x has the total shaded area equal to 0.81 on the diagram? So I'm going to go to the screenshot here. You can see, once again, I have selected that we're taking the value from an area, and I've input that the area that we're interested in is 0.81, and again, mean of 0, standard deviation of 1, since we're calculating z-scores. And once again, here's our answer, that our z is equal to negative 0.878. Now what that negative means, negative z's are to the left of the mean, and I'd like you to notice here's our value of z, and it is in fact less than 0 if you take a look at the x-axis. So let's take a look at this in action. We're going to do a full example. Here's our full example. A botanist is studying the growth of a certain type of tomato plant. She finds that under certain growing conditions the diameter is normally distributed, with a mean of 35 millimeters and a standard deviation of 3 millimeters. So let's pick out the information that we need, it does in fact say that we've got a normal distribution here. We also can read off that our mean is 35 millimeters and the standard deviation is 3 millimeters. And the question asks us to calculate the following. 90% of these tomato plants will have a diameter larger than a certain value. Calculate that value. Now, if we were to just draw a little picture here, and again, on your test number 3, you don't need to draw a little picture. You could do so on your scrap paper on the side if you wanted to. But basically what we want to do is we want to color in the area that is 90% above a certain value. So if our mean here is 35 millimeters, and we're saying here's our x up here, we want to draw a line and have 90% of the area be above that line. So I'm going to draw the line like down here somewhere, and then this entire shaded region up here is going to be equal to our 90%, and then the value, our particular value of x of interest should give us a value that's below 35 millimeters. So again, writing this out, our mean is 35 millimeters. Our standard deviation is 3 millimeters. Our probability P is equal to 90% or 0.90. And so we throw that into our handy little calculator. Notice that once again, I'm going to highlight the fact that we're choosing the second of the options, where we're finding the value from an area. We've put in the 0.9, which is the area that we're interested in. Actually, I should use blue to be consistent, so we put in our area 0.9, our mean of 35, and our standard deviation of 3. And notice that down in the results area, we're looking for above, and so our answer here is this is our result. So we get x is equal to 31.155. Now recall what x is. X is a diameter of a tomato plant, and the units were in millimeters, and so this is going to be millimeters. Now this table gives a lot more precision than you really need. This to me, we're not really trying to get too much into sig figs or anything like that here. But what I'm going to say is this would be an acceptable answer, but I am more likely to round it to say 31.2 millimeters would be my answer, or even 31 would be totally fine as well. So I'm going to do a separate little video in which I do a full example using the online calculator and the normal distribution, and I'll see you in that video.